Hi, I'm Margot,
Hi, I'm Anesu.
and we're going to talk about Newton's first and second laws.
Imagine an alien spaceship from the planet Ares. It is cruising towards Earth at a constant speed of 26.6 kilometers per second. We consider it from the reference frame of Earth.
The spaceship is in space, so there's no friction or drag. After leaving the planet's atmosphere, the Aerasians turn off the engine, so there's no force propelling them forward either, but the spaceship doesn't stop moving.
Newton's first law states that an object that is at rest will remain at rest, and an object that is in motion will continue to move with a constant velocity in the same direction if and only if the net force acting on that object is zero. This means that objects have inertia, that they do not change speed or direction without the action of an outside force.
No forces are acting on the Eurasian spaceship. It began with a constant velocity of 26.6 kilometers per second and continues to move without changing direction or speed. However, Newton's first law states that the net force must be zero. Even if there are forces acting on an object, it can still maintain constant velocity provided that these forces cancel each other out.
Within the ship, the regions move at the same constant velocity. To them, the ship is an inertial reference frame. This means that objects within the frame do not accelerate without a contact force of some kind. On Earth, objects within inertial reference frames still undergo the force of gravity. However, since they're in space, the regions float around like human astronauts. Fortunately, they have green tentacles that can help them attach to walls and maneuver around.
As the Eurasians approach Earth, though they are still at a distance where the effect of Earth's gravitational field is negligible, they decide to slow down and review their strategy for domination. By expelling fuel from the front of the spacecraft, they create a force of thrust that directly opposes their motion of velocity.
Newton's second law states that net force equals mass times acceleration. The only force acting on the spaceship right now is the force of thrust. Since we define the motion of the spaceship towards Earth to be positive, and since the force directly opposes this velocity, this force is negative.
The force of thrust acting on the spaceship is minus 800,000 newtons, and the mass of the spaceship is 2,000 kilograms. We can rewrite it on second law as acceleration is equals to force over mass. Thus, the acceleration of the spaceship is minus 4,000 meters per second squared.
Once the spaceship starts accelerating, it is no longer an inertial reference frame because this violates Newton's first law. The Eurasians now feel pulled towards the front end of the spaceship. Assuming Eurasians too have invented spring scales, they can now measure their weight. Weight is distinct from mass. It is a measurement of the force that an object does on a spring.
Let's look at how to measure the weight of an Eurasian. The force of the spaceship on the Eurasian is equal to the force of the Eurasian on the spaceship. We know this because of Newton's third law. Continue studying physics to find out about it. The force of the Eurasians on the scale is equivalent to the force of the Eurasians on the ship. The alien's acceleration is still minus 400 meters per second squared. The mass of an individual Eurasian is 140 kilograms. Since force is equal to mass times acceleration, the force of this Eurasian is 140 kilograms times 440 meters per second squared. The weight of this Eurasian is 61,600 newtons.
To recap, Newton's first law describes the inertia of an object. Newton's second law states that force equals mass times acceleration. Remember that an inertial reference frame does not experience an acceleration, and that weight is a measurement of the force exerted on a scale.
Good luck with your studies.
And beware of Eurasians.